In this video, we will discuss symmetries of the graph of a function. So when it comes to symmetries of a graph of a function, we actually lose one of the symmetries we had earlier. You can have a y-axis symmetry or an origin symmetry. Since the graph of an equation of a function has to pass the vertical line test, we are not allowed to have an x-axis symmetry. So we will say that a function f is even if f of minus x equals f of x for every possible input. And that is completely equivalent to saying that the graph is symmetric with respect to the y-axis. Similarly, we will say that a function is odd if f of minus x equals minus f of x for every possible input. And note, this is equivalent to saying that the graph is symmetric with respect to the origin. The nice thing is, determining even and odd really comes down to just doing some basic manipulations with the function and seeing what happens. So for this first function, 3x over x squared plus 1, let's determine what type of symmetry is present, even, odd, or neither. So what we need to do is evaluate the function at minus x. So replace each of the x's that we see with a minus x. And then the question becomes, how is this related to that original function f of x? Well, in the top, that's minus 3x. And in the bottom, the quantity minus x squared is exactly the same as x squared, because when you square a negative, it goes away. And this is minus, from the minus in front of the 3x, the function f of x. Because note, when you pull out that minus sign, the function f of x is left over. So looking back at our definitions, f of minus x is always minus f of x. The given function is odd. So let's check a few more functions. So for the function g, we're going to do these same manipulations. So g of minus x, replace each x with the minus x. 2 times minus x plus 3 minus 2x plus 3. And, well, looking at what we have, minus 2x plus 3, that's not equal to the function g of x because of that minus sign. But at the same time, it's not equal to minus g of x because of the plus in front of the 3. So this function has no symmetry to its graph, neither. Lastly, for this function h of x, if we replace each x with the minus x, that becomes the square root of minus x quantity squared plus 4. When you square minus x, that's the same thing as squaring x, and that is our original function. And whenever h of minus x is equal to h of x for every input, that means that the symmetry of the graph of the function would be even.